students for the Polytechnic Oklahoma. I am Naiwan.
I am Divashini, daughter of Tangure.
Today we are going to present our engineering math assignment, and its topic is trigonometry, theories and its application in architecture.
Good day, I'm coming in from DBM10013. Today I'm going to present about fundamental of trigonometry function. Definition of sine, cosine, and tangent. Sine equal to opposite over hypotenuse, cos equal to adjacent over hypotenuse, tangent equal to opposite over adjacent. A capital letter is always used to label the angle, while small letter is used to label length. Cosine is equal 1 over sine, sec is over 1 over cos, cot is over 1 over tangent. Values of trigonometry function for a special angle. You guys can refer to the right hand side. Two are a sample question. Number one, sine 60 degree. So let's see the answer. The answer is 0.866. You just press sine 60 to get the answer. Number two, sec 18 degree. It's a bit different. We need to press 1 over cos 30 to get the answer. Let's do another question. Find the value theta. Sine theta equals 0.82. So we need to press shift then sine 0.82 to get the answer. Number two is 2 sec theta. We need to press shift then cos 2 over 5 to get the answer. Okay, quadrant. We can draw a circle around the origin in anti-clockwise direction that split into 4 equal parts, or we can call it quadrant. Each quadrant will take 90 degrees. Reference angle. Reference angle is the actual angle between the terminal arm or terminal side and the x-axis. The reference angle is always positive. Sign of trigonometry function. Every quadrant has different formula, such as quadrant 1 is all, quadrant 2 is sine, quadrant 3 is tangent, quadrant 4 is cos. We can use all science teachers are crazy to memorize the formula. Okay, let's do some example question. Theta equals to 150. 150 is at quadrant 2, therefore 180 minus 150 will get 30 degrees. Number 2, theta is equal to 4 pi over 5. Pi is equal to 118, therefore 4 times 118 divided by 5 will get 144. 144 is at quadrant 2, so 118 minus 144 will get 36 degrees. Another example question is sin theta equals to 0.82. The 0.82 is positive, so sine positive is in the first and second quadrant. We calculate the reference angle first. We will get the answer is 55.08. To calculate the second quadrant, we just need to minus 118 minus with 55.08. So we will get the answer is 147.06.
Hi guys, we are talking about the trigonometry equations and identities. For the introduction, trigonometry has a lot of equations and identities. They are used to transfer an equation into another form in order to simplify the calculation of an unknown value in the equation. In our syllabus, there is a part of equations and identities we need to learn. For the Pythagorean identities, first and foremost is sine power 2x plus cos power 2x equal to 1. And 1 plus cotangent power 2x is equal to cosec power 2x. And tangent power 2x plus 1 is equal to secant power 2x. Compound angle. By following the equation below, like sin A plus B is equal to sin A multiplied cos B plus cos A multiplied sin B. If we facing the situation like sin A minus B, then our equation will be sin A cos B minus cos A sin B. Now we are talking about the double angle. For the first part, sin 2A is equal to 2 multiplied sin A and multiplied cos A. And a little special for the cos 2A because there is 3 equations for it. And 3 equations can get the same result with the cos 2A. First and foremost, cos power 2A minus sin power 2A. And the second is 2 multiplied cos power 2A minus 1. And the last part is 1 minus sin power 2 and multiplied with A. And for the tangent 2A is equal to 2 multiplied tangent A and divide with 1 minus tangent power 2A. Now we are going for the example questions. Given sin A is equal to 5 per 13 and cos B is equal to 8 per 10, such that A and B is an acute angle. Calculate the value of 9 per 4 multiplied sin A plus B and 3 secant power 2A in fraction. The calculation is showing as the screen. The information given by the question and we can use this is sin A equal to 5 per 13 and cos B 8 per 10. I have already highlighted them. Therefore, we can build triangle A and B based on the information. From the diagram triangle in the previous slide, we can calculate the value of sin A and cos A. Sin B will be 6 per 10 and the cos A will be 12 per 13. By using the theory we learned just now, according to the formula compound angle, sin A plus B is equal to sin A cos B plus cos A multiplied sin B. We can transfer 9 per 4 sin A plus B into 9 per 4 multiplied with sine A cos B plus cos A sine B. Then we can write down the calculation as below. We have solved the first part of the question. For now, to solve 3 secant power 2a, we need to use the formula tangent power 2a plus 1 is equal to secant power 2a. Similar with the method shown above, we can translate 3 secant power 2a into 3 tangent power 2a plus 1, and we learned that the tangent a is equal to sine a per cos a. Therefore, we can write down our calculation as below. And then we have solved the question by using the theory I have presented just now. Now we are talking about the sine rule and the cosine rule. For the introduction, the sine rule and cosine rule are used to solve any triangle problem. For examples, to find an area of a triangle, length of a side of triangle, and angle of a side of triangle. The slide showing right now is about the basic theory of the sine rule. The capital letter ABC we can consider as the angle of the triangle, and the small letter of ABC we can consider as the length of the triangle. To find out the length and angle of the triangle, we can use the formula that I showed on the screen. Now I'm showing you guys the cosine rule equations. There is 3 of them. 3 of them I can use to find the length of the triangle or the angle of the triangles. And the formula of area of a triangle, we can use it to find the angle of a triangle or find the area if the triangle is not the accurate 90 degree. And that's all my part. Thank you for listening.
Good day everyone. I'm Divashini, daughter of Tangudurai from DBM10013 to share application of trigonometry in architecture. Trigonometry is used in architecture to calculate roof slopes, ground surfaces, light angle, structural roads, heights and weights of structures. Trigonometry helps engineers and architects to draw angles, calculating precisions, measurements and determining height of the structures. So here are uses of sine, cos and tangent. For Pythagoras theorem, to calculate length of diagonal of a rectangular beam or the hypotenuse of a right triangle. Sine, cos, tangent, they can calculate angle, forces involved in various shapes and congruence, such as trusses, arches, and polygons. Here is some world famous building which is built by trigonometric angles and structures. Here is the question which is used trigonometrical of architecture application. So the question is, John takes selfie from the bottom to the top of Paris Tower and measures the angle of elevation is 31 degree. Then is moved back under 28 meter in the same line from the building and the angle elevation is 26 degree. So calculate the height of the Paris Tower using trigonometry method. Before we start to calculate, we have to structure a diagram which is include our angles and some diagram to our reference. So here it is. So here x is 31 degree. So y is 26 degree with the 128 meter distance. So now we want to calculate height. So for calculate height from sine, cos, tangent, we are going to use tangent. So tangent is opposite over adjacent. So it's simply as called as TOA. So to calculate the tangent of 31, it is h over x. So x equals to h over tan 21. That is equation 1. So next for 26 degree, which is tan 26, h over under 28 plus with x is equation number 2. So we are going to substitute equation 1 into 2. So tan 26 degree equals to h over 128 plus with h over tan 31. So we are going to simplify that so that we will get tan 26 degree multiple with 184 tan 26 degree over tan 31. As a step 5, which is 128 tan 26 degree times with tangent 31 degree plus with h tan 26 equals to h tan 31. So we are going to simplify that equation and we will get 128 tan 26 degree times with tan 31 degree equals to h multiple with tan 31 minus tan 26. So we will get 128 tangent 26 times with tangent 31 over tangent 31 degree minus with tangent 26, which is equals to our height. Calculate by using tangent is 331.59 meter, which is proven by the original height of the Eiffel Tower. So that tangent is proving to calculate height of the buildings. As a conclusion, we can conclude that engineers and architects uses trigonometry to design and analyze the strength, stability, and aesthetic of structures, such as for various of angles for bridges, buildings, dams, towers, and domes. So that we can say that trigonometry is really playing an important role in architecture. So here is some reference and credits to the respectable honors from the website and also a book called Trigonometry and Architecture. Thank you for lending your ears.